This video will be on section 13.1, exponential and logarithmic functions, or equations rather. So we'll just break this down into two parts. The first part we'll look at solving exponential equations, and the second part we will look at solving logarithmic equations. Right. So in order to solve exponential equations, an exponential equation is just an equation where the variable is in the exponent. So just peeping down here, this that says solve 100 or 10,000 rather to the x power equals 1 over 100. And when you want to solve an equation like this, there are two ways to do it. One is the one-to-one property. So to kind of explain what this means, sometimes this is necessary, sometimes it's optional, sometimes it doesn't work at all. And we'll see when that is. But this one-to-one property says a to the x equals a to the y. And then we have this double arrow, which means it's equivalent to x equals y. Really, the way we want to read this is if each side has an exponent with the same base, that's why we have a and a, then we can set the exponents equal. And so if you could imagine that x is up here in the exponent and you really want to get rid of this a, one of the ways to do it is like this. The other way, this way always works. If you can use the one-to-one property, it's usually quicker. But if you can't use the one-to-one property, the other way is to switch to log form. And really, you'll have to use this. This is must be used if you cannot make the same base on each side. Alrighty, so we're going to use one of those two in all the problems. I'm really just going to show you the one that's better in each one and explain why it's better. The third option, which sometimes it can be used, I'll show you an example. We'll also have an example. It's really similar to the second one. So if you have an exponential equation and you get the exponential part by itself, which I'll explain what that means when we get to the problems, then you can do the natural log of each side. And this is one of those things where you can use this in place of the second one. So used in place of switching to log form. All right, so just reiterate the one-to-one property. It's the quickest thing to use when you can use it. If you cannot use it, you'll use one of these two things, switching to log form or doing the natural log of each side. All right, so for the first one, we want to solve 10,000 to the x power equals 1 over 100. Now what I want to look at first here is that 10,000 and 100 are both powers of 10. Why do I care about that? Well, that means we can get the same base on each side, a base of 10, and use the one-to-one property. So we can make each side with a base of 10 and use the one-to-one property. Right, now you should be a little familiar with switching things to powers of 10 because it's just counting the zeros. But what we do first is just change on the side, change the 10,000 and the 100 to powers of 10. Oops. Change to powers of 10. All right, if we had like 2 and 16 over here, then we would change the powers of 2 and stuff like that. All right, so powers of 10 is pretty straightforward because you just count the number of zeros. 10,000 equals 10 to the 4th power, and 100 equals 10 to the 2nd power. All right, so let's go ahead and plug these in. And we get 10 to the 4th power. Notice we're replacing 10,000 with 10 to the 4th power, which is 10 to the x power, so that's why it looks like 10 to the 4 to the x equals 1 over 100 is 10 to the 2nd power. Right. And now we have a 10 on each side, but we still have to simplify it a little bit further. We cannot have two exponents like this, so we want to combine these into one. Your exponent rule that you should have seen prior to this course. When you have exponents raised to exponents, we can simplify them to one exponent. And when we have exponents to exponents, we multiply them. Right, so this one, if we multiply the exponents, we get 4 times x. So the left side is really 10 to the 4x power. Now on the right side, because 10 is in the denominator, we really need it in the numerator. Being in the denominator is not helpful. All right, so we need the 10 in the denominator. Sorry, in the numerator. And we know if we bring up the 10 from the bottom, we have to make the exponent negative. Make it change sign. Since we want to bring it up. But let me rewrite this, because if yours is negative here, then when you bring it up, it would become positive. It switches sign. Right, so on the right side, 1 over 10 squared becomes 10 to the negative 2 power. Once you've done that, it really is pretty easy from here because we have the same base. Now, notice that it looks exactly like this form. A is 10, our base is 10 on each side, and our one-to-one property says set the exponents, not the insides. Set the exponents equal and solve. All right, so if we set the exponents equal, we got 4x equals negative 2, and divide by 4, and you get x equals negative 2 over 4 is negative 1/2 simplified. Now I'm only going to point this next little thing out because when we get the logarithmic equations, it's a little different. Since the domain of exponential functions is all real numbers, you don't have to check your answers for these. Right, when we get the logarithmic functions, our domain of a log function is 0 to infinity, which means when you do solve them, you might add in answers that aren't really answers. So you have to check your answers for those. All right, so the next one, solve 5 times 3 to the n power plus 38 equals 443. Now we mentioned this before very briefly, but something like this, 5 times 3 to the n is simplified. You cannot make this 15 to the n because only 3 is being raised to the n power. Now this one looks a lot more complicated than the previous one. What you want to do when we want to solve exponential equations is get the exponential part by itself, which by that I mean 3 to the n, the part with the exponent. All right, the 5 is just multiplying it, it's not with the exponent. The 38 is not with the exponent on it. So we want to get this part by itself, almost as if what was inside this box was x. So if you had to solve 5x plus 38 equals 443, how would you do it? I'm going to rewrite the problem just to give myself the room to work. And like I said, get this part by itself just as if it was x. So we subtract the 38 from each side, and we get 5 times 3 to the n power equals 443 minus 38 is 405. And then to get rid of the 5, since it's multiplying 3 to the n, we divide by it. And we got 3 to the n power equals 405 divided by 5, which is 81. Right. Now this one you might not know off the top of your head, but 81 is actually a power of 3, which means we can make the same base. And the power of 3 it is the fourth power. So 81 equals 3 to the fourth power. You can check it in your calculator. Now if you're thinking, I don't know that off the top of my head, how did you figure that out? You can just do this. You can multiply 3 times 3 times 3 times 3. And if you skip over your number, then it's not going to work. But this one works. So we can plug that in and use the one-to-one property. And also, unlike the last one where we noticed that these are both powers of 10, I wouldn't want to try to break it down any further because 3 is already a prime number. And what that means is, we can't write 3 as a power of anything except 3, at least easily. All right, so we replaced the 81 with 3 to the fourth. We got 3 to the n power on the left. The parentheses is useless now because the 5's gone. And 81 is 3 to the fourth. Now we set the exponents equal, since the base is the same. And when we do that, we are actually just at our answer already. N equals 4. All right, so this one, once we realized we could do the one-to-one property here, there was no extra work because the exponent was already just n. All right, so these two both could be done using the one-to-one property. Not all of them can be done using the one-to-one property. But you don't know that at the beginning, so you really have to play it as you go. All right, so number 3 says solve 3 times 5 to the x divided by 6 power equals 27. All right, so the first thing we want to do is, like last time, get the exponential part by itself. All right, the exponential part here is the 5 to the x divided by 6 powered. Right, the exponent can be anything at all. It can be a fraction, just the letter, whatever. When we say exponential part, we mean the base with the exponent. So if I want to get this part by itself, I want to divide each side by 3 to get rid of that 3. And when we do that, we have 5 to the x divided by 6 power on the left. And on the right, 27 divided by 3 is 9. All right, now this one, you would want to ask yourself the same question. Can we get the same power, the same base? But the answer is no, because 9 is not a power of 5. Right, as soon as we go 5 to the second power, that is 25, so we skipped over 9. So either you have one of the two options. You can switch the log form, or do the natural log of each side. Now I'm going to show you how to do it both ways for this first one, and then I'll probably switch to doing the natural log of each side for the rest. So way one, switch to log form. Remember, to switch to log form, we grab the base, which is 5, and move it to the other side. On the left side, what's left here is the x divided by 6. And the right side, we have log. Its base is 5, and the inside is 9. Right. Now this is just a number. We don't want to mess with it yet. It depends on what the question asks. You might want to type it in your calculator and get an approximate answer. You might want the exact answer, which means leave the log. But either way, you don't have x by itself yet, so don't use the calculator yet. So we want to get x by itself first. And getting x by itself here isn't too bad, because what you would do, once again, just realizing that this is just a number. You know, if you had x over 6 equals 2, you would multiply each side by 6. We do the same thing here. We get x equals 6 times log base 5 of 9. Now I like to put the number in front. You can put it in the back. The one place it cannot go is with the 9. Right, the 9 is inside, the 6 is outside. So they cannot touch each other. It's like having 9 inside of a square root, 6 outside. You can't multiply them unless they're both inside or they're both outside. All right, so this is what would be called the exact answer. If you want the approximate answer, so some questions ask for one, some ask for the other. I was about to write appropriate, approximate. Answer. What you do is you type it in your calculator. And this is part of the reason why we did that change of base formula from before, is we want 6, then log base 5 of 9. We do the ln of the inside divided by ln of the base. And we get 8.1913 if we round to 4 spots. Right. And the question, it just might ask one or the other. For the previous ones, when you can find the base and do the one-to-one property, you don't have this messy decimal to worry about. So the second way to do it is, I'm going to take it from here again and do the natural log of each side. Most people like doing it this way because feels more like doing the same thing every time. So very literally what you start with is put both sides in a natural log. So we have the natural log of x divided by 6, or sorry, 5 to the x divided by 6 equals the natural log of 9. Either way, you have to remember some log rules, exponent rules, switching forms. The next step is to move the x out front. Move the exponent out front. Right? Think about why this makes sense. We're trying to solve for x. X is inside the log. We don't want it in there. We would like it to be outside, but you can move it outside with our log rule. So our equation becomes x over 6 times the natural log of 5, right? Because we took out that, only 5 is inside, equals the natural log of 9. And once you're here, it's just the same thing as last time, only when we get x by itself, we want to multiply each side by 6 to get the 6 gone, but we also want to divide each side by the ln of 5 to get that away as well. All right, so we want to multiply by the 6 to get rid of the denominator. We want to divide by the ln of 5 to get rid of that and have only x left. And when we do that, we have x equals this. If I rearrange it, it's multiplication of fractions. I like to put the number in front like before. So we have 6 times the natural log of 9 on top and only the natural log of 5 on the bottom. And that's a different way to write this. It's the exact same thing. And I'll just point out that if you thought these numbers would end up different, they shouldn't. They should be exactly the same. But that what we put here is exactly this when we typed it in our calculator using the change of base. So one of the benefits of doing the natural log of each side, that method, is you automatically get the change of base inside the final answer. Right, so that, like I said, that is one advantage. But pick either one that you like and do it like that. But like I said, going forward, if I am not allowed to use the one-to-one property on a problem, I'm going to do the natural log of each side 99% of the time. All right, so this next one, it looks a little more complicated because of the exponent, but if you keep in mind that, just getting the exponential part by itself, it'll put your mind at ease that this really isn't a lot different than the previous one. So we want to solve 12 times e to the 4x minus 1 power, then minus 8 equals 9. And just like the previous one and the one before that, we want to get the exponential part right here by itself. I don't want to simplify or try to simplify anything. I want the e to the 4x minus 1 by itself. Right, so I'm going to rewrite it just like I did with the other one to give myself the room to work. Once again, just think of the exponential part as x. If you had 12 times x minus 8 equals 9, what would you do? You would add 8 to each side. So we got 12 times e to the 4x minus 1 equals 9, plus 8 is 17. Divide each side by 12 to get rid of that, and we got the exponential part by itself. E to the 4x minus 1 equals 17 over 12. This fraction doesn't simplify. All right, now, think about what e is. It's, that 2.71, you're never going to match e with the power of a fraction or a whole number. You're going to have e on this side as well, which we do not. So here we cannot get the same base. So what I'm going to do is I'm going to do the natural log of each side. Now the way I wrote it before when I did the natural log of each side is the way you have to write it. If you just write ln on each side, it doesn't make any sense. So I'm going to start by doing that. We get the natural log of e to the 4x minus 1 equals the natural log. Make sure you put in the whole fraction here. Right, since the fraction's already there before, it's going to be all inside the natural log. Now, if you actually remember the rule here, you'll remember that ln and e actually cancel out. So before ln and 5 do not, but ln and e cancel out, and we're left with just the exponent. Right, that was one of the last problems we did in the last section. So the left side now is just 4x minus 1 equals the natural log of 17 over 12. And then once we get here, it's a lot like the last one again. When we had we had x over 6 equals ln of 9 last time, times ln of 5, we solve for x. We're going to solve for x again, just keeping in mind that this is just a number. How would you solve 4x minus 1 equals 2? And so we would add 1 to each side. We have 4x equals 1 plus the natural log of 17 over 12. I prefer to write the plus 1 in the front. You can write it in the back. Just once again, 1 is outside, 17 over 12 is inside. Then the last step to get x by itself is we divide each side by 4. And the exact answer is what we have here. X equals 1 plus the natural log of 17 over 12 all over 4. It's very, very messy, but that's just what it is. And if you want the approximate answer, we type that in our calculator and round it. All right, so our numerator is 1 plus ln of 17 divided by 12. Close that off, so that's our numerator, and then we divide it by 4, and we get 0.3371 as our approximate answer. And once again, some of the homework questions ask for both, some ask for just one. You just figure out which one at once and go from there. All right, so finally, the last one looks really different in the sense that we want to solve 4 to the 7x minus 5 power equals 1 over 4 to the x minus 6 power. What should look very different to you about this problem is that we have exponents with x on each side. But I will say a big thing is that we don't really want to think about it differently. What I want to do is notice right away each side is just an exponential part. So unlike the previous ones, there's no solving to get an exponential part by itself. What I really want to focus on is notice that we can get the same base on each side. Right, because we can write 4 and 1/4 as both as a power of 4. Well, 4 is already a power of 4, it's 1, so we can rewrite 1 over 4 as a power of 4. And actually, I'll just, since it's a fraction, it's pretty easy to think about, well, we want to flip this fraction. So to flip 1 over 4 to 4, we must multiply the exponent by -1. Right, that's really what we do when we say switch the sign, is we multiply it by -1. Because there's an x there, maybe it's a little more confusing. What do you mean switch the sign? So what we'll do, the left side is already a power of 4. We don't have to change that. And the right side, 1 over 4, if we flip it, we get 4 over 1. And then we multiply the exponent by -1. All right, so we flip the 1 over 4 to 4. I actually just left it as 4 over 1 to make it more obvious in our first step. And then we multiply the exponent by -1 to keep it the same. All right, now I'm going to go ahead and just simplify the left side, sorry, the right side. 4 over 1 is just 4. Distribute the -1 through, we get -x plus 6. And now you can see we have the same base. We can set the exponents equal to each other. And we get 7x minus 5 equals -x plus 6. Add them up. solve for x. So we add x to each side, and then add 5 to each side to get the x's on the left and the numbers on the right. And we got 8x on the left. 6 plus 5 is 11 on the right. And we divide each side by 8. And we get x equals 11 over 8. Since this is just a nice fraction, there wasn't an ln in our final answer. This is good. You won't really be asked for the approximate answer for something like this, just the exact. All right, so that's a really good summary of exponential equations, solving them. Now we'll move on to solving logarithmic equations. So a logarithmic equation is an equation in which the variable to be solved for is inside a logarithm. So something like this, if we want to solve for x, see the x is inside. And the general strategies of solving a logarithmic equation is one of the following ways. All right, one of them is also a one-to-one property. But it's more obvious when to use that with log equations, as we'll see. So if you have a log on each side with the same base, what we will do is we will set the insides equal. Just like this says. It says log base b of x equals log base b of y. It's the same as x equals y. Now the other option is like the second option from the exponential equations. Whenever you solve a log equation, really if you don't have a log on both sides, you're going to do this every time. So if you have log on only one side, what you will do is get the log by itself, the log part by itself, then switch to exponential form. So part of the reason why, there's always balances, why log equations can be easier than exponential equations, is you have two ways to do it, and the situations you do them is very, very different. If you have logs on both sides, you will use the one-to-one property. If you have it only on one side, you will not use the one-to-one property. You will switch to exponential form. Now, the one thing that you have to be careful on, so the big warning I have here, many of our log rules work only when the input is positive. And you can kind of work out, which is why I have it written like this. Anytime you solve a log equation that starts with more than one logarithm, you must check that your answer is valid in the original equation. And there's a reason why I have the original all capitalized. But keep in mind that you don't have to check if you only have one logarithm in your equation, because you won't be using any of the rules that break or add in unnecessary numbers. All right, so the first one here, it says solve the following logarithmic equations for the given variable. Make sure to check your answers when necessary. Your homework does not say this part. That's just me reminding you of what I just wrote. All right, so the first one, you got 5 plus 4 times log base 8 of x plus 5 equals 21. Now it looks a lot for the first one, but we want to focus on getting the log part by itself. And I want to start by thinking of this the same way I did the exponential stuff. If the entire inside of this was just x, how would you get x by itself? Well, you'd subtract that 5 off and divide by the 4. So we want to do it the same way. I want to subtract the 5 off. And we get 4 times log base 8 of x plus 5 equals 21 minus 5 is 16. And then we divide each side by the 4. All right, once again, thinking about if this was just x. We got log base 8 of x plus 5 equals 16 over 4. It simplifies to 4. Right, so if that was just x, we'd be done because this would be x, but we want to solve, what's actually written here. Now, because you don't have a log on both sides, you, at this point, want to switch to log form, or switch to exponential form. You cannot switch to exponential form in any of the previous parts because you can only switch when you have only a log over here. The number out front, the 4, the 5 being added on are both bad for us. All right, so to switch to exponential form, we grab the 8, the base, and we move it to the other side. When we do that, what's left on the left side is the inside x plus 5. And on the right side, we have 8 raised to the 4th power. All right, so you got to remember that. The base goes over here, stays the base of the exponent, and then our 4 is the exponent. The inside is what's left. Now 8 to the 4th, let's just do that in our calculator because that'll be a whole number and pretty big whole number at that. 8 raised to the 4th power equals 4,096. So x plus 5 equals 4,096. And now you know how to solve this. So you just subtract 5 and get our answer. We get x equals 4,091. Right, and that is our answer. We don't have to check it. You can, but you'll see in the problems that we are forced to check what can go wrong. We only had one log here in the problem, so we don't need to check. Okay. All right, so the next one, it looks a little bit simpler, but because of the base, we'll see there's a little more to do at the end. We have the natural log of 7x plus 3 equals negative 3. The idea is the same. It doesn't matter what the base is. You want to get the log part by itself, and this one already is. It doesn't matter how messy the inside is. Everything on this side with the log is inside the log, nothing outside of it. So we want to switch to exponential form. I'm going to rewrite our equation here. Remember, our natural log is when there's an invisible base e. If you want to, write it in, and then move it to the other side. So we get 7x plus 3 equals e to the negative 3 power. Now, since e isn't the greatest number, this would be very messy. It's not a nice number to type in your calculator, so just leave it alone for now and solve for x. We want to get x by itself here, so we subtract 3 from each side. On the left side, we are only left with 7x. And the right side, we have negative 3 plus e to the negative 3. Once again, if you prefer to put in the back, you can have e to the negative 3 minus 3. But also, just like with the other problems from before, this negative 3 is in the exponent, this negative 3 is not, so we cannot interact them at all. Right, and then the last part to get x by itself is to divide each side by 7. We got x equals negative 3 plus e to the negative 3 all over 7. This would be our exact answer. And if we want an approximate answer, we'll type that into our calculator. So let's do that. Our numerator is -3 plus e raised to the -3 power, and it's divided by 7. And we get -0.4215. Right, now, like I mentioned before, since you have a single log, this is going to work. We don't need to check our answer. If you're thinking, well, you can't have negative numbers inside logs, you are correct. If you plug this number in, you will find out that it becomes positive. When you multiply this by 7 and then add the 3, it becomes positive. All right, so that is our answer. Now the last two here I have here, you'll notice both of these have more than one log in them. So for these, we will have to check our answers. So I'm just going to write a comment here. We need to check the answers we get for this one. We might get more than one, so we also need to check answers for this one. They both have more than one log. All right, so what do we do when there's more than one log on a side? What you want to do is combine them into one. All right, so always combine logs on the same side into one log when solving an equation. Right, because the end goal is, if we look back at our strategies here, notice that the one-to-one property has one log on each side, so you want one log at most on each side. And then when we switch to exponential form, there's only one log on one side. So either one you're going to use, you must have only one log on each side. Right, now to combine this right here, subtraction becomes division, and there's no numbers out front to move. So we can do it right away. So just a reminder from that, subtraction outside becomes division inside. We get log, and our fraction inside is x minus 2 on the top and 1 minus x on the bottom. And that equals 1, what's on the right side. And now we can switch to exponential form because we have one log over here. It doesn't matter how messy the inside is, we have one log over here and our number over here. And nothing is outside of the log. So remember, when our base isn't written with log, it's really base 10. And we get x minus 2 divided by 1 minus x equals 10 to the 1 power. Now 10 to the 1 power is just 10, even though there's not much to do there. I'm going to rewrite it before I move on. And now we want to solve this for x. Okay. Now one thing to do, we've seen a lot of problems like this in this class now. If we have a fraction on each side, it's best to think about 10 being 10 over 1 and then cross multiply. Right, we always want to get rid of fractions if our x or whatever's in the denominator anyway. So we cross multiply. The left side we have 1 times x minus 2, and the right side we have 10 times 1 minus x. And now distribute and solve for x. Distribute the 1 through, which does nothing. The left side is x minus 2. The right side we distribute the 10 through, and we get 10 minus 10x. Right, so I'm going to move that up here, give myself a little more room. and solve for x. Add the 10x, bring the x's to the left, and add the 2, bring the numbers to the right. And on the left side, we got x plus 10x is 11x, and on the right side, 10 plus 2 is 12. And then divide each side by the 11 to get x. Right, but I am not boxing this in yet. I am not saying this is an answer because we must check our answers. This is not automatically going to work anymore. And I'll remind you, when you check, you need to plug into the original and check. If you plug it into when you've already combined them, what's going to happen is it's automatically going to work, because when you combine them, you're assuming everything works. So anytime you combine logs, that's why we have to check our answer. All right, so I'm going to plug in the x equals 12 over 11 to the equation here and see if it works. We get log of x, which is 12 over 11 minus 2, minus log of 1 minus 12 over 11 equals 1. And we're just asking, is that true? Does this equal 1? If this side, when we type it in, equals 1, we're good. If it does not, then we have actually no solutions. All right, so let's check it out. So we have just the log here, log base 10. We got 12 divided by 11 minus 2 in the first, and then minus log of 1 minus 12 divided by 11. And what do we get? We get an error, which means it is not a solution. Right, that means the only possible answer we had actually isn't an answer, which means there is no solutions to this one. And that's okay. Anytime you solve an equation, you always have the possibility of no solutions. Now, sometimes people mess around with some settings on their calculator, and what's actually happening is this is some imaginary number. So if you hit if you type that in and you got your answer as correct, it's because you, excuse me, set your, oh yeah, it's in mode. If you click on mode here, what should be highlighted down here? You have real, and then you might have a plus bi and this other thing. If you have a plus bi highlighted, it will give you the correct answer. So, I mean, the wrong answer. So make sure you have this real highlighted. Otherwise, it will give you the wrong answer for this specific problem. It will not pick up when there's an error. So once again, that's click mode. Make sure you have real highlighted here. All right, so that is one example, and also brings in, problems, the properties from last section. The next one, we have the natural log of x plus the natural log of x minus 5 equals the natural log of 4x. All right, now this one is going to work differently, but before we get anywhere, we must do what we did last time and combine the two logs into one on each side. All right, and once again, we don't have any numbers in front on these, so we're good with that. We have a 1 in front of each. We can combine them, and addition outside becomes multiplication inside. All right, so we get ln, and we multiply the insides, x times x minus 5 on the left. The right side is already one log, so we don't have to worry about that. Now, one thing I would do here is just simplify the inside x, distribute that to the x minus 5. We get the natural log of x times x is x squared, and x times negative 5 is negative 5x. And now we're sitting here. Now what you might notice is this looks different than the other log equations we've solved because we have a log on each side. This is when you use the one-to-one property. And we set the insides equal. All right, so x squared minus 5x equals 4x. And we solve this. And honestly, the one-to-one properties, when you can use them, especially for logs, is pretty great because it just gets rid of the logs and you don't have to mess around with them at all. All right, so we want to solve for x. We have different powers of x. That means we want to factor. Subtract the 4x from each side, get 0. We got x squared minus 9x equals 0. And then this, we can factor an x out in common. And we got x minus 9 left inside because we took x out of x squared and x out of the negative 9x. So we got x times x minus 9 equals 0. And then set each part to 0. Yeah, x equals 0 and x minus 9 equals 0. Right, and then the one on the right here isn't solved for x yet, so we got to add the 9 to each side, and we get x equals 9. Right, but once again, just like the last one, we have to check our answers. Okay, so I'll do x equals 0 first. Plug it into the original. Do not plug it into where we've already combined anything at all. Plug it into the original. So when we plug in 0, we get ln of 0 plus ln of 0 minus 5 equals ln of 4 times 0. Now this, you can type it in your calculator, which I'll do for the second one. But I want you to actually remember here that the inside of a log cannot be 0. And if any one part of it breaks, it's all broken. So since ln of 0 does not exist, this is not a solution. All right, so no luck yet. X equals 0 is not a solution, so I'm going to mark it out. But if you typed in the whole thing over here, you get D and E as well. The reason I wanted to just say that is because if you type in both sides, you get D and E for both. You know, technically that sounds like it's the same, but it's D and E. It's not an actual answer. All right, so finally the last one, x equals 9. Plugging it into the original, we get ln of 9 plus ln of 9 minus 5 equals ln of 4 times 9. Now, one thing I'm going to do real quick is just simplify this. The 9 minus 5 is 4. And 4 times 9 is 36. You actually don't need the calculator for this one because we know to combine these. They're both positive, and 9 times 4 is 36. Addition becomes multiplication. But if you just want to check your answer, go ahead and do that. ln of 9 plus ln of 4. The left side equals that number. And the right side, ln of 36, equals the same number. Right, so since both sides give us the same number, it doesn't give us D and E on both sides. This is an actual answer. Right, so x equals 9 is the only solution for this one. Right? But as far as log equations go, that's a good rundown. If you have one log, get it by itself, switch to exponential form, get your answer like we did in the first two. If you have more than one log, you must combine them into one and then use the appropriate method. But more importantly, if you have more than one log, check your answers. We saw out of the 3 possible answers with these 2 problems, only one actually worked. Now all of them could have worked, but none of them could have worked as well.